Each startup will have 4 minutes to present their pitch, 7 minutes following for judge questions. We have $10,000 worth of prizes today, which is the first prize gets $7K, second place gets 2, and first place, I did that whole in a weird way. Third place gets $1,000, second place gets $2,000, and first place gets $7,000. That being said, we can go ahead and start. I will introduce you to Austin Rosenbaum of Demand IQ.
Good morning, everybody. Thank you for joining us here today. Appreciate the opportunity to do this, Z Prime, Jason, and everybody. Appreciate the opportunity and excited to share with you what we're working on at Demand IQ. As Ricky mentioned, my name is Austin Rosenbaum. I'm the founder and CEO of Demand IQ. And the story I'm going to share with you today is about how we help the Orlando Utility Commission, also known as OUC, deploy more behind-the-meter storage and solar. When thinking about this program, OUC had really 3 main concerns. One, how do you get demand? How do you get customers excited and interested about solar? The status quo method of marketing solar and storage is to knock on doors. And I don't know if you have had folks come out to your house and knock on your door, but it's not all that pleasant, and customers don't love that. So they wanted to take a different approach. The second thing that OUC was interested in was how do we actually convert interested parties into customers at a higher rate through better education and sales, and who would actually do that selling, because a utility company is not equipped to sell solar panels. They're not trained, and they don't have personnel who will do that. And third, how do we guarantee that customers are going to get a high-quality installation and that the work is going to be done in a great way? So to address that customer experience problem, specifically around folks going out and knocking on doors, as I mentioned, they wanted to eliminate that idea. We provide a proprietary tool that we call Stella. It's a web-based conversational AI that lives on the Orlando Utility Commission website. It engages with homeowners and provides instantaneous solar quotes. So it crunches all the numbers and gives back transparency on what the solar can do for the homeowner, that is the savings, cost, environmental benefits, and other components, so that homeowner can have peace of mind that what they're shopping for is something that they actually want to purchase, and in doing so, they can buy and not necessarily be sold solar. Once this product is installed on the website, it engages with homeowners, but it also connects them with a contractor who's local to their area and can deliver that project to the homeowner. So in this marketplace concept, we pair the demand with the supply so that homeowners are matched with the appropriate provider and that the utility doesn't have to do any work with finding that contractor and ensuring that that project gets delivered. And I'm sure you're wondering, so who are these customers or who are these contractors that we're entrusting with our customers? And so we take a very data-driven approach on who is an appropriate contractor for doing this work. And so we look at things like Net Promoter Score, average days from NTP to install, and other KPIs that we use to determine who is a good qualified contractor to match with your customers. So in practice, what does this look like? We place this iframe, it's an embeddable widget, directly on the homepage of the Orlando Utility Commission's site for their solar page. A homeowner can go and insert their address and answer a few questions to get qualified and get back a return like you see on the right side of the screen, showing the solar value to that particular homeowner, things like savings, cost, and other factors. It also qualifies the leads, books appointments, and does other customer intake steps so that the customer is fully intaked into the business. So results of this, 2 megawatts of solar installed. When we look at the status quo method of marketing, you see usually only a 3% pull-through from lead to close. We actually achieved a 12% pull-through, and this is all attributable to the transparency and integrity that we provide through opening up the information to solar entirely online. When we look at our competitors, the main differentiators, it all really centers on trust. So our approach, conversion rates and conversion rate optimization, focuses on trust. And in order to achieve that, we are embedding this on the site so we don't move from your website to, let's say, energysage.com. That's a drop in trust. And the other one is we're really looking at local sales teams. We're backstopped by the local contractors and their sales teams as opposed to having a remote sales team somewhere in California like Electrium. Okay, last thing here. So you might not be doing solar and storage today as a program, but we are expanding into other things like EV charging and DR programs, smart appliances, and other things coming soon. So if that's something you're considering, I'd still love to chat with you. Thanks.
All right. Thank you, Austin. And now we will begin judge questions.
Okay. So talk a little bit about your engagement with utilities. What lessons did you learn with Orlando, and what kind of hints do you have for the audience filled with utility executives here on how to become a good partner with you?
Good question. So one of the biggest things that we learned from our data, so actually a little bit more background on Demand IQ. So we actually started as a vendor for solar companies. So utilities are a bit newer for us, but what we've learned through our data with our 200 solar contractors that use this technology is that the pull-through rates to customers closing when doing it through a utility is significantly higher. So that trust factor is so important. You have all these relationships already, and if this is something you're considering, rather than farming this out, just using a lightweight technology like Demand IQ will allow you to benefit from that trust and engagement that you already have with your customers and pull more solar through rather than just completely outsourcing and farming it to some solar contractor themselves. Other lessons learned, this thing is pretty lightweight. There's not a lot of work for the utility, so we actually help them to implement some of their marketing as well. So if you want to do customer segmentation on your database, we'll help you with your email blasts and other types of event triggers to get customers to engage with this page. But yeah, I mean, the main thing was that the trust was through the roof and that the conversion rates were really strong.
Can you talk about that trust through the lens of equity?
Through the lens of equity?
Yes.
Do you mean like equity amongst different populations, or?
Building trust is an important part with any customer group, right? And if you're using an algorithm or a bot to drive what that trust is and transparency, how does that how is that received by diverse groups of potential customers?
So we actually offer this experience in both English and Spanish. That's actually no one else is doing 2 languages, bilingual communication. We focused on that because we realized that there are underserved populations, particularly here, in Texas, where this is, important for them to learn about. But speaking to them in a language that they're familiar with, that trust is why we decided to build it in Spanish as well.
Can you talk a little bit about the project costs and how much it would cost a utility to engage with you?
Yes, absolutely. So we actually charge on sort of a success fee basis based on the number of interactions that the bot has. So it's an order of cents, on 50 cents to $1, depending on how many interactions you have. So it would really depend on the scale of the pilot, the number of homeowners you're reaching, and so forth. So it's hard for me to provide an exact number without knowing what size your utility is and how many meters you service, but it's based on the number of interactions.
What's your financial picture?
Our financial picture?
Yeah, as in what's your revenue? Yeah, what's your revenue run rate? Is it a ARR model?
Yep, we're at about 1.5 million ARR. We launched this product about 2.5 years ago and grew from 0 to 1.5 million in that period. We're adding about 15%, 10 to 15% per month right now. So doing pretty well on the growth story, and we just closed a $2.25 million series seed, and then we have raised about almost $3 million to date.
Who was the lead on the seed?
It's a large angel who did the same technology in automotive. So I cold LinkedIn messaged him. I was like, hey, you did the same thing in another vertical. Are you interested in being a partner? He wrote us a $2.25 million check.
So with the funding that you've received and the fact that you are trying to break into the utility space out of solar, what is your strategy for moving forward?
So certainly here to learn a lot. That's the main reason I was here aside to pitch, but to learn from you all as to how you think about these programs. I also think that it's not just about solar and storage, it's about electrification as a whole, and other components to, behind the meter engagement. So yeah, we're still creating that playbook around addressing this market, but definitely creating relationship and relationship-based selling, identifying who are interested parties with any of these technologies, and then having those conversations.
I like the fact that you actually showed some expansion areas. I think there's probably a lot more than that, especially in competitive markets when you're trying to market competitive electric supply. And I know door-to-door sales is terrible in that field as well. I think that's something you guys can definitely explore. My question is, as you expand into these different areas, I think at some point you're going to start competing with utilities' own virtual assistant solutions. So how do you anticipate to go around that?
Yeah, that's definitely fair. I would love to see what utilities are doing on par with what we have. I haven't seen anything quite like this yet from the utility side, but certainly self-service is a big trend. When it comes to customer adoption and the marketing side of things, I think there's more activity being done in the call center support side, like support escalation. There's other terminology that is out there for this, but on the demand generation, lead generation side, and marketing side, there's less being done in the self-service bot side. So I don't know that this is like a one-for-one replacement with the existing technologies out there. That said, we do have APIs stood up to be able to do some of this stuff with other user interfaces. So if there's open APIs with any of those technologies, we would be open to integrating potentially.
We have about 1 minute left for questions, if judges have one last question.
One of the conversations yesterday was about how customers don't necessarily think of their utilities when they're thinking about EVs. So this sounds like the customer has to find the utility page and use your product. What are you doing to reach out or to educate people who don't know about solar panels or the likelihood of it?
So what are we doing aside from working with utilities to directly engage with their homeowners? And you mentioned EVs in particular, which is very interesting because around 60% of people who buy an EV end up adopting solar batteries. So that same angel that we got to come on board, his technology is this company called Roadster. They work with over 10,000 automotive dealerships. So they have a point-of-sale solution, a digital e-commerce buying solution very similar to what we have for automotive. We're in the process of integrating that point-of-sale solution with our technology so that when you buy an electric vehicle, you can cross-sell and get a battery storage and solar system at the same time. It's a little bit different than the marketplace play that we have here with solar, with what I shared for the utilities. But nonetheless, that's how we're creating more demand in the market through cross-selling. So bringing more of these technologies like EV chargers and batteries to the customers and doing push marketing as opposed to like kind of the pull approach.
All right, and that's time. Thank you. Our next presenter is ClearTrace.
Good morning, ETS. My name is Zach Livingston, and I'm the head of sales for ClearTrace. And one of these buttons will change the slides. There we go. ClearTrace is an energy data and carbon accounting company addressing one of the biggest challenges in decarbonization, which is the lack of credible and verifiable data behind emissions. We provide an hourly carbon accounting foundation combined with energy traceability to track the true source, time, location, and environmental characteristics behind both energy generation and energy consumption. That is then mixed with a patented 24/7 load matching engine to match every hour of energy consumed with a renewable or carbon-free resource. We're a team comprised of 25 people based right here in Austin, Texas. We are post-Series A and will soon be announcing a Series B. So for today's case study, I'm going to focus on one of our core customers in JPMorgan Chase. JPMorgan has aggressive sustainability commitments around carbon neutrality and 100% renewable energy, and is managing a complex and distributed portfolio of more than 5,000 locations spread across the globe. Like many others, they started out with the lowest hanging fruit, which was driving energy efficiency inside their facilities. And when that wasn't enough, they went out to market and started buying RECs, or renewable energy credits. They realized quickly that RECs alone were not going to suffice, as they could not quantify the true environmental impact associated with these RECs. Furthermore, they were lacking the actual generation data associated with the RECs and realized that these RECs were not actually doing anything to decarbonize their local energy consumption. They realized that they were going to need immutable proof and auditability to stand behind their claims while breaking down data silos with data being spread across a number of different software players. So enter ClearTrace. ClearTrace provides a single consolidated view across JP Morgan's entire portfolio globally. We first integrate with their near real-time energy consumption by leveraging smart meter technology across commercial offices, data centers, call centers, and thousands of retail branch locations spread across the globe. That is then combined with hourly grid mix tracking to track the balance between clean to conventional power on a local grid at any given time. We then pull in any on-site generation data, on-site solar, fuel cells, batteries. And lastly, we pull in any off-site procurement, things like PPAs, competitive retail supply, and RECs. This is then enriched with hourly emission factors to track the true locational and temporal impacts of that generation and consumption, and then is driven to the ClearTrace user interface to manage that information at scale. Lastly, we provide a consolidated reporting output to align with things like the GHG protocol, RE100, and 24/7 carbon-free energy. Related to their offsite procurement, they went to market for competitive retail supply in deregulated markets, and ClearTrace was directly written into these RFPs. In New York ISO, Brookfield Renewable was selected, and ClearTrace integrated with Brookfield's entire hydro river supply in upstate New York. We then provided market links to the New York ISO system to track the settlements and transactions. What this ultimately provides is tracking the generation as produced upstate, settled and delivered downstate, and then ultimately consumed by JPMC in New York City, effectively visualizing farm-to-table electrons generated upstate and consumed downstate. This is then mixed with our hourly carbon accounting and load matching framework, and ultimately gives JPMC visibility that Brookfield is meeting their contractual obligation for delivery of green electrons. So this all sounds super cool, right? But what does this mean for JPMC? It provides them with a single source of truth and ultimately gives Alex Saltikoff, their global head of sustainability, that digital and data-driven attestation to stand behind their claims while reducing the risk of greenwashing. It also enables them to view everything they do with a carbon lens and really prioritize carbon decision-making into portfolio decisions, while also navigating evolving regulatory standards, whether on a local level, such as Local Law 97 in New York, or federal level, such as mandated SEC disclosures.
All right, and that's time.
Thank
Judges, your 7 minutes begins now.
Zach, could you talk a little bit about the relationship with the utility, in this case, NextEra Energy? Are you really just working with the utility's commercial customers like JP Morgan, or what is the tie into the utility?
Yeah, so two things. One, we're a B2B SaaS business, so we're not working with residential customers. The utilities are a couple things, right? Utilities have all these smart meter implementations for the most part, and in some cases make that data accessible. So we work with the utilities to leverage their smart meter programs to get access to that data. The NextEra example you mentioned was actually us working with their Optos software, which was a market optimization capability alongside JPMC to really co-optimize alongside energy and carbon and really look at day ahead and real-time transactions based on both price, energy, and carbon for JPMC. I will add, I had a slide on utilities, but I was going to run out of time, so I didn't go to it. A couple things. Time and location and granularity are super important to carbon, and we feel that utilities should be leveraging that information to understand true impacts. I will also add that utilities have many green choice programs, right? Many of them use RECs. We see an opportunity to enrich those programs with more traceability behind where that generation is actually coming from. And then lastly, we see a lot of opportunities for new incentive programs. How do you optimize EV charging at times when peak emissions are lowest? How do you look at demand response programs that also look at when peak emissions are highest, right, and reward customers for doing so? So we view all those opportunities to really look at new programs from a utility-centric mindset, really with carbon in mind.
I think it's a great solution. Certainly is something that's a lot of utilities and a lot of energy companies are looking at. I have one question. I don't know if it's fair to ask it to you because at the end of the day, it's a policy question. When you work with a utility, like you said, it opens up the data access problem within that utility. as a generator ourselves, in my company, we have access to real-time generation data, but we find it very difficult to access customers' real-time consumption data. My question is, how do you scale? Because every utility territory you go to, you're going to end up dealing with the same problem. And it is likely, I mean, policy will not be able to keep up with this, to open grid data and all that stuff. How do you plan to go around that problem?
Yeah, it's a great question. You know, the data problem is real, right? And we don't brand ourselves as a flip of a switch solution. We align with companies' digital transformation strategies, with many of them putting significant capital investment into building management systems, smart meter deployments, sub-metering. We also see the evolution of programs like Green Button Connect and Smart Meter Texas. I don't know if Shuli Goodman's in the room, but we just joined LF Energy, which is looking to solve some of those challenges. You know, and the reality is that we like to use the mantra of you can't manage what you can't measure, but you can't measure what you can't meter. You know, companies have to put the capital investment in to understand their data. Data is the new oil. So we see utilities driving that, we see the market driving that, we see new consortiums driving it, and we see companies putting specific capital investment into it.
Is this on? Can you speak more about like immutability? I'm saying blockchain, but not only from your internal power consumption and usage as a company, but speaking more to like scalability across several users, right? Blockchain and blockchain solutions, as they start to scale out, if you're talking about multiple users accessing that type of data in a market environment, to be able to provide the type of immutable, trusted transaction data that you're talking about, like how does that play into just not only the overall kind of delivery of the product, but continuing to like not drive up carbon costs as part of the solution itself?
Sure. You know, hopefully I don't lose the audience in starting to talk about blockchain. I like to say that we're not a blockchain company. Blockchain is part of our tech stack, just like cloud services are part of any company's tech stack. It's really the last step in our process if companies are using this for public attestation is to anchor the data to a blockchain. So we're not just putting all data on a blockchain because we can. Part of the key piece of that as well is the actual exploration of the audit trail. So when companies are actually taking this information to a Big Four consulting firm, they're spending a lot of money for them to effectively just manage spreadsheet information. ClearTrace effectively digitizes that audit trail, speeding up the audit process and enabling to look at shared savings models. I will add that we're also part of the Crypto Climate Accord, which is really looking to decarbonize blockchain usage and crypto mining and things like that. And a lot of the Hyperledger cloud providers, Google and Microsoft, are also putting a lot of work into decarbonizing their cloud. So we pay attention to these things. As we grow, we will continue to add priority around it. And we do look at the different blockchain technologies we're using from a carbon consumption standpoint as well.
Can you speak to some of the challenges perhaps that you had when you were rolling out the pilot or project with JP Morgan?
Sure. Reliability of data, data consistency, access to data, I think challenges that we all see. As we scale to different countries, the Europe electricity system looks very different from the US electricity system. The electricity system in India looks very different from the European electricity system. So how we tackle those geographic differences is something we think about. The other thing I'd add is just the sustainability ecosystem is evolving every day, right? There's new regulation, new protocols, new standards. So we definitely try to keep an eye on how things are changing. Where do we see kind of consolidation and consistency across this evolving regulation and ecosystem? And try to be ahead of where the market's going. But I would say the data access challenge is our biggest challenge.
What would be your response if somebody wanted to use your product but they had a large remote workforce working from home? Can it be leveraged that way?
Potentially. So I should add that today we are only doing scope 2 emissions, mostly electricity and steam. So we're not doing scope 3 and looking at things like employee travel or what remote workers are doing. We're focusing on large electricity consumption, right? So this is either large centralized portfolios like a data center, crypto miner, or large commercial skyscraper, or distributed portfolios like a JP Morgan, bank portfolio, or a McDonald's, Subway, these type of companies. So we're currently not looking at home environments to quantify those emissions.
All
Okay.
right, and that's time.
Thank you.
Our next pitch is from Armada Power.
Good morning. My name is Eric Rayberg, and I'm the Chief Engineer for Armada Power, where our mission is a cleaner, more resilient power grid. So, like many of you here, we also believe that the future of electricity is renewable. And quickly, the challenge isn't so much how much solar or wind we can deploy, but how much storage we can deploy to support it. And so 10 years ago, I was part of an engineering team at the Battelle Research Institute, where we were tasked with making the largest impact we possibly could, but we had a really small budget. So it forced us to look for the most cost-effective solutions for storage. And that led us into the home. So the electric water heater in your house is every day storing a tremendous amount of energy. It's storing it as thermal energy that you can use to manipulate for grid purposes. And we manipulate the storage within the tank within milliseconds to support things like renewables firming, as well as system resiliency, without anyone even noticing that you've done anything to that tank. And there are 40 million of these electric water heaters out there, and they're pretty demographic agnostic, right? Whether you live in a big house or a small house, you probably have an appliance that makes hot water. And so the hardware component costs about $150 in quantity. It takes about 15 minutes to install. It's UL listed, doesn't affect any of the safeties or warranties on the tank. And we've been operating in the PJM system for over 6 years. That's 24/7, 365 days a year, providing ancillary services. And we've generated over 20,000 megawatt hours of frequency regulation and growing. And we've also been deployed in 10 different states and in Canada as well with different utilities. And we're able to stack a variety of value streams. So in addition to ancillary services like frequency revenue and demand management and cold load pickup savings, these are actual payments and revenues in some cases, depending upon the jurisdiction that you're in. So it's not just a cost savings measure, but it can actually generate revenue for you. We had a situation with a multifamily partner, so this was an apartment complex, where a single event, we saved them $40,000 by avoiding a peak set after an outage, and also helped them restore power faster without anyone actually impacted in terms of comfort. And that's in addition to the revenue streams that we produce for them all year round. So what about the comparison to the status quo of storage, lithium-ion batteries? Well, you could deploy a residential lithium-ion battery, or you could deploy about 40 of our water heaters, which would get you about 5 times the amount of demand effectiveness and about 10 times the storage. And something like a water heater lasts about 3 times as long as a lithium-ion battery. So where does that take us into the future? NREL has estimated that by the year 2050, we're going to need about 200 gigawatts of storage to support an 80% renewable grid. That's 2 orders of magnitude larger than what we have today, because most of our storage today is actually pumped hydro. So the amount of resources it's going to take to create that many batteries is just tremendous. But if we were to outfit the 40 million electric water heaters that are out there today without any additional electrification, we would pick up about 20% of that goal right there. And I think most of the discussion around storage has kind of been around the obvious solution of, the sun shines during the day but doesn't at night. There's a whole tranche of storage in this 4-hour to 4 millisecond range that supports grid stability and system inertia that is also extremely important. So a thermal asset like water heating, which can switch within milliseconds, is extremely capable of supplying those kinds of system inertia needs that are going to be need to be replaced. And so I think what we're essentially doing here is kind of revolutionizing the way that people think about demand. No one used to get into cars to hitchhike as a reliable form of transportation until companies like Uber and Lyft connected and automated the transaction process. You could turn your water heater on and off in time with a wind farm somewhere, but it's just not very convenient until you have a technology that automates it in a secure fashion. So we're transforming those thermal assets into a reliable grid storage asset. Thank you.
All right, we'll start judges. Your questions begin now.
I had a question. So it sounds like you have a number of deployments, and thank you for the review of your case study. But looking forward, what do you see as your next steps?
So I see expansion in 2 ways. One is essentially additional kind of energy products, right? So we have a really established way of performing things like frequency regulation and ancillary services, and of course demand management and capacity management. But I think there's additional ways to productize things like renewables firming or even supporting system inertia. we can support them from a physics perspective, but there's a lot in terms of what needs to happen on kind of like the regulatory side for energy products. And then, of course, there's always the expansion into other technologies as well. So we do water heating really, really well. I think we can do other appliances really well as well. Thank you.
Talk a little bit about how you're going to scale the solution into the megawatt and gigawatt.
Yeah, that's a great question. The nice thing about aggregating lots and lots of small assets is we've gotten really good at large-scale computing, right? So ingesting tremendous amounts of data, our algorithms are automating and running these things in an efficient manner. And so adding more and more water heaters is an extremely simple process. It's just like Netflix. Like if everyone's streaming the latest show, you just spin up more instances to absorb that data, and that's how we've architected our system as well.
Just one question on the wholesale market. So I assume you just aggregate these thermal storage into a virtual power plant and bid into the wholesale market. How does your bidding strategy compare to, let's say, large grid-scale batteries or any other type of virtual power plants? I'm assuming also like there are other kinds of thermal storage like refrigeration and stuff like that. So how does that compare? Where do you see in terms of yourself in terms of competition?
Yeah, that's an excellent question. So, just like any other grid resource, right, we're doing load forecasting out, weeks, days. We have an operations team, a really great data analyst that we've added to the team that he's developing all these forecasts. So we essentially look at what's happening with the load shape that we're going to be deploying against. How are we optimizing against price prediction? And then it becomes kind of an opportunity cost game, right? So like, do we want to supply ancillary services, or do we want to support maybe a demand constrained feeder? It really depends on the particular deployment and the particular customer set that we're working with. But it essentially just rolls into our operations as you would for any kind of other dispatchable resource.
Piggybacking on that a little bit, can you talk more about just kind of doing the cost comparison between traditional batteries? It looks like you're dealing mostly with residential hot water heaters. The scalability of that, issues of that, and just the deployment costs. There are states like California, certainly, that you're going to see an uptake of hot water heaters. But what about the rest of the country, and how does that compare to just investing in more traditional batteries?
That's a great question. I don't see batteries as being in competition to us. I actually see us as a hybrid solution to those batteries. So electrochemical batteries are great because you can store energy for really long periods of time and then get it back out. But the challenge with them is they have, there's costs associated with it. There's raw material costs. There's round trip losses. And then they also have cycle life too, right? So each time you discharge or charge that battery, it's essentially a capital cost because you're degrading its life. So I see us as actually really teaming up with batteries. So let's take things like water heating, which can switch on and off within milliseconds, and they last, extremely long time. And let's use that to soak up those small variations. And then let's work with the batteries to say, all right, let's control their charge cycles based on their thermal constraints, extend the life of those batteries, and then kind of use them for the larger, longer-term storage aspects. So I think when you take a look at your original question there on kind of costs, right, like how do you break that down? I think we need to look at the total cost benefit of kind of a hybrid solution like that. So, yes, if you're going to deploy a battery, why not also control the water heater next to it, have them work together. Now you've kind of done that in the same truck roll, and you're essentially picking up that hybrid benefit.
So it seems that you've been working on this for quite some time. And I know that a lot of people in this room probably already recognize the standard challenges that you've come up against this. What has surprised you about working on this kind of solution, and what is the biggest barrier that you have right now?
That's a really great question. I think anytime you try to innovate in the utility space, you have to solve a number of different problems, right? There's always the engineering problem. It has to be reliable, has to be secure. But then it's an industry that's highly driven by regulatory policy, right? Because of just centuries of the way that the system works. And that's, anytime you have complexity, you also have opportunity. So I see it as not necessarily a barrier, but it kind of illustrates the path. So I would say the next steps are really, understanding the different jurisdictions that we want to serve. What are the goals of the regulatory stakeholders? What are the goals of the different utilities, whether they're investor-owned or municipal or cooperative? And then really kind of unlocking value for them and saying, hey, we've got a solution here that's a sort of general purpose storage solution. How do we help you capture the value stream that's relevant to you in your jurisdiction?
Thank you. And so if that is what you are going to have to do, how exactly are you approaching those conversations, or what is your path to success?
Well, some of it is getting involved in events like this, right? So creating mind share. So showing people that, hey, we shouldn't just be looking at maybe, one solution for storage or renewables integration, getting that mind share so that, as we approach different stakeholders, they can say, hey, I'm familiar with something like what Armada Power is doing. This makes sense for the environment, for our system, has a good business case. So it's really a combination of strategies like that.
Well, all right. If we have no more judges' questions, thank you so much to Armada Power. Our next presentation comes from Innovation Force.
Good morning. I'd like to invite you to take a visualization exercise with me to get started. I invite all of you to close your eyes. We're going to time travel back to 1985, the year where Pac-Man was king and a little company called Blockbuster was just getting started by a Dallas entrepreneur. I want you to remember, what was it like to get in your car and how excited we used to be able to pick that video up off the shelf. The smell of popcorn in the Blockbuster, and then the realization that your neighbor just stole the video that you wanted to rent. And you pick the next best one, and you go to check it out, and you find out you owed a late fee, right? What a great customer experience that was. No wonder they're no longer around. Now we're going to fast forward in time 7.5 years into the future to the year 2030. You're in a car. You're driving down the highway. You need fuel. And you pass the gas station to your right that's boarded up and abandoned. Don't worry. You're going to take a right, and you're going to turn into the EV charging station to charge your EV vehicle. I want you to take a moment to think about the car. What car are you driving? What is the brand? Take a look at the station. What is your experience? Take a look at the placard and tell me, what is the brand of the charging station provider? Is it the same or different than the car you're driving? You can open your eyes now. Good morning. My name is Kim Getchen. I'm CEO of Innovation Force, and my message is simple. If we don't think radically differently about the way we're innovating, we run the risk of becoming the next Blockbuster in the year 2030. The good news here is we're at ETS, and you all are the change agents that are bringing the new ways to innovate back to your utilities, and we can do something different about it right now. And so did our customer, Portland General Electric. They asked us to reimagine the way that we could innovate in the future. So we came up with a way for them to run innovation in 90-day sprints, use cases that could be scaled across industry partnerships that involve, by the end of 12 months of innovating together, 100 different innovators touching 30 different solution provider partners. We were able to run 40 different use cases in a use case library, and we identified up to $340 million in potential savings, along with a couple industry firsts. So the good news is this was a whole new way of innovating. It was really driving results, but unfortunately, even that wasn't fast enough. So we had a problem. Either we needed more time, which was finite. We would either have to hire a bunch more people, which wasn't an option, or we could rethink the technology to go even faster. We chose the technology. Innovation Force is the first purpose-built SaaS platform built for utilities and with utilities to automate workflows, measure the process of automating, and report it back out in dashboards so you can have a real-time view of just what's going on in your innovation process. So what's next for us? Well, we'll be establishing more use cases in our use case library, supported by our industry partners, and our beta platform, the SaaS platform, will be available this summer. And we are looking forward to being able to work with all of you. Thank you.
All right, judges, you can begin your questions now.
You mentioned the use case library. Do you make those use cases available across all of your customers so there's really that knowledge sharing that's taking place? And also, how does that contribute to the investment profile that one of your customers, may be looking at to partner with your services?
Yes, so the use case library, most utilities have an ideation process. They have many different ideas and problems they're trying to solve. So we've taken that, built a use case library around it, and we go out into the industry working with accelerators, incubators, startups, academia, and solution providers to match the solution provider to the actual problem statement in the use case the utility's trying to solve. This is really good for two fronts. One, it's going to save that solution provider a lot of time, right? So they're going to get walked into the utility and be able to tell the utility how they're going to solve the problem immediately. And the utility doesn't have to worry about going out and sourcing all these new ideas. That's all put together in a use case. It's hosted in the platform, as well as being able to pick and choose different use cases from the platform. One thing to know is that this platform will create network effects, right? So all innovators can come together and be able to find problems and solutions faster. So what I see here is really just an acceleration and taking out a lot of the noise in the process. Imagine not having to sit through a bunch of sales pitches, right? Now solution providers can come to you and say, hey, I can solve that problem. Here's how I would solve it. And then you can share those lessons a lot faster across the entire community that you're working with, which will no longer be just utility executives. It's going to be the utility folks and your industry partners all working together to solve problems faster together.
Is there like an ideal customer profile for you when it comes to the type of utilities that would be best suited for this software?
Right now, we're really looking at working with IOUs to get the best learnings. And then I think over time, we would be able to make it a lot more scalable into co-ops, for example, and munis. We're very excited to be able to scale the technology and right-size it for different sizes of utilities. But currently, we're approaching IOUs.
What's the underlying platform?
So the underlying platform is going to be built on it's a SaaS developed platform. We're in prototype stage at this moment, and then working towards the development. We're vetting the different technology providers right now.
If I could just do a quick follow-up. So what is that? What would be a differentiation between your solution versus a plethora of C3 AI, Palantir, Vertra? There's a plethora of innovation platform solutions available now in the utilities domain. How is your solution any different?
Yeah. So frankly, we're going really, really deep in the process of the execution of innovation. So what we've seen to date is a lot of CRM platforms like Salesforce or HubSpot, ideation platforms. So they're bringing in different ideas from the organization, but we have not seen anything to date that takes a workflow that's proven, automates that workflow, and then creates the network effect around the automated workflow so that the right person can get involved at the right time, at the right place in this process. So we're going super, super deep on how to execute, and that's what I think makes us a little bit different. We're doing this with utilities, so working on it together with the utility to truly understand how do we reduce the man-hours spent per person in the innovation process. So the scale of success for us is to be able to measure the number of man-hours per person and get that number reduced so the innovation process can go faster and avoid throwing bodies at this problem. We do believe that's different. We haven't seen anybody really focus on the actual steps that it takes to innovate, measure it in real time, and then visualize it. We recently did a survey, and we released it this morning. 53% of people surveyed have zero metrics for measuring innovation, and $1.7 trillion was spent on innovation last year globally, and this is unacceptable. So we're coming along to solve that problem with the automated workflows and the visualization in the dashboard to optimize the team performance and reduce man-hours per person spent.
The utility business has let's call it a strong legacy of ideas about how things get done.
I'm sorry, I couldn't hear you.
It's like a strong cultural legacy of how decisions are made and things get done, right?
Yes.
Workflow automation aside, building the perfect mousetrap, how have you seen with your, in the example with Portland, how's it changed culture and the ability to actually make decisions at the executive level and to deploy ideas?
I'm so glad you bring this up because this is actually why I got involved in this. I was researching and thinking through how we could make innovation a better process, and I felt like culture was going to be the big inhibitor. We actually dropped our survey this morning. It turns out culture is not the inhibitor. I was shocked to find that the majority of respondents felt that they worked in organizations where it was safe to fail and they felt supported by their culture. Now, utilities in particular have a different challenge than I think other verticals. Utilities work in very siloed, department-driven, and ways of working where it's difficult to collaborate, right? So I think utilities and addressing that cultural issue takes a lot of alignment. You need strategic alignment between the ideas you want to run through this process first. And so through our connected utility model, we work with the utility to figure out what is their North Star in the innovation front. We help them categorize the use cases they want to run in a framework, and then we push those use cases forward. Now at Portland, I'm actually involved in helping them strategically align around this new process. But my goal is to make sure that we are aligned from the C-suite to the front line in an innovation process. One thing we do that's unique is we gather day-in-the-life learnings during our field trials. And I'm just not seeing that being done anywhere. And so by being able to take in the learnings from somebody who's out there for the first time using a tablet to download information from an ADMS system, and they can't find connectivity, and therefore that makes them late to their kid's soccer game, those are the sorts of findings that we're sharing with the C-suite as part of our 90-day innovation sprint.
All right, and that's time. Our next presentation comes from the UMS group, InfraShield Labs.
Thank you very much, Kim. That was exceptional and certainly a tough act to follow, but I'll try. So I really want to tell you guys about how we went for the past year toe-to-toe with Amazon, IBM, Tomorrow.io, and others. We spent the last year working in a district in South Florida to show that we have the best system in the market to actually go through and predict storm outages and help optimize response. Before we get into how we actually showed that, I want to talk just a little bit about the system itself. So our DRX WeatherGuard is really a first of its type to use semi-supervised advanced machine learning to take in elements such as historical and real-time forecast data, asset outage history, historical staffing in response to storm restoration, and GIS data, and then takes all of that in a semi-supervised manner and compares that to the upcoming forecast of what the weather is going to do. And what it's able to produce is a circuit-level outage prediction optimized crew levels for the projected outage, and optimized forward crew locations. And we can send that all on customized alerts straight to the field. So is that just a better mousetrap? And the answer is no. The answer is this is truly a quantum leap forward. What we did is we spent 6 years in R&D with over 100 utilities. We learned from them. We understood how did they actually predict storms, how did they restore after the storm, and what were all of the variables and parameters that went into that. That really allowed us to see machine learning and only semi-supervised machine learning would do. And what that looked like then ultimately was a level of granularity that drove a level of accuracy that ultimately made this actionable. Previous first-generation programs like IBM's Weather Intelligence, DTN's Weather Sentry, they closed their storm prediction window at 72 hours. That's not nearly enough time for you to actually be able to take any sort of action, because all you were saying is, within the next 72 hours, we're gonna have some amount of outages. What we're able to say is, within 1 hour, this is what the level of outages is going to look like on a circuit level. So you can go point a trouble man right where it's supposed to be. He can check it out and say, yep, get a crew out here or don't. But what that's allowed us to do is get to that 90% accuracy level. So ultimately, what we're now able to do is move from a CYA tool to a you bet tool, right? You can bet on it. What are the benefits of that? Right? What are the benefits of getting away from just CYA and actually taking action in this space? Well, first, we can improve KD by 15 to 20 minutes in crew allocation. That's particularly true if you don't have AMI in place. But we can also do about 18 to 25 minutes off in restoration. And when you think about the national median KD being about 89 minutes, that's a substantial reduction, which doesn't just help you with regulators, it helps you with customers. We can also reduce crew call out by about 35%, reduce unnecessary truck rolls by up to 20%, and perhaps most importantly, eliminate unnecessary work on the weekends for your teams and allow them to be able to get some of their time back, because instead of having to constantly re-optimize for a poor forecast, they're able to sit back and say, yeah, I know exactly where it's going to be and I'll get alerted if I have a problem. And we're able to do all of this for less than the cost of one storm response for a medium-sized thunderstorm. So with that, I'll open it up to questions.
Talk a little bit about the secret sauce behind getting to 90% over the commercial services from IBM and Amazon.
So first and foremost, you've got to get closer to the storm. So one of the learnings we discovered during this pilot phase is that the majority of your outages, even in a very storm-prone area like a Florida or a Texas, are not during hurricanes. They're not major storm events. It's actually that Friday afternoon thunderstorm after everybody's already at the bar. So you have to bring that window much, much closer to where you freeze your forecast. That's one. The second was the machine learning. It started spitting out ideas and things that were not a part of traditional models. Barometric pressure has an impact on whether or not the assets are going to fail in a storm. Other atmospheric conditions have an impact. And so as you start to embrace the power of semi-supervised machine learning, what you start to realize is it starts pointing you and saying, a little bit like dark matter, we're not sure what it is, but there's something missing here, and we need to add in some variables. And that's ultimately what drove that.
Tell me about the 100 utilities that you work with. Who were the, how did you put such a large consortium together?
Yeah, so we're very lucky. We have a sister company, UMS Group, that is been spending the last 30 years bringing utilities together around different topical and thematic elements through learning consortia that they call. And right now they have about 100 different utility members that come together on a quarterly or monthly basis to talk about key themes, discover best practices. So there's a ready-made set of utilities who are coming to UMS Group, our sister company, and saying, hey, there's something that's burning a hole in our head right now. Let's talk about it. And we're able to then go, yeah, well, that's interesting. Here's what we're working on. And here's what we're going to do about it, and what do you think? And that iterative process is very organic, because for them, it's not a sales process. For them, it is truly a co-development, co-creation process. We're pretty mature in terms of our financial stability, right? So we're at about 1.75 ACV. We're in our second round of capital right now. We did our first round ourselves. We're fully funded for the first 10 years of our existence. We went and got a whole team of developers and data scientists 10 years ago. We funded that out of some of our own pockets. And now we're saying, okay, in order to truly scale, because of the success that we've really started to unlock with this machine learning, it is time to go out and get that external funding. And so we're now seeking that from various investor arms from the regulated utilities.
I have a question about the requirement of a utility that wants to leverage your product in terms of the historical data, right? Obviously, weather is very regional and specific to a service territory. So, what are the expectations of a utility in providing you with that legacy data source to get the value out of the tool?
Yeah, so the legacy data is of critical importance. And actually, in this use case down in Florida, we only got about 5 years because they just did a major system upgrade 5 years ago. So we only got about 5 years of data, which actually has hampered some of the forecastability, particularly around the weather, which is always the weakest variable in the chain anyway. But even with just 5 years of data, 5 years of outage data, asset, health, history, everything else, we were still able to get to 90%. And so what we do is typically just want to expose an API. As long as the cybersecurity folks are comfortable with that, we expose an API that can ingest all of those different data sources. And we also can pull in third-party weather as needed. But what we've found is typically the credibility of the tool is better if the meteorology team within the utility is actually saying, yeah, this is the forecast we trust, and this is what we're going to go with. But ultimately, it's not dissimilar to any sort of system implementation where you say, okay, here's our data ingestion, let's go through it, let's normalize, let's take a look, does this make sense? And then we're off and running.
Are there other potential applications for your technology in the future? And if so, what does that look like?
Yeah, absolutely. So this was really focused on wind, right? And that Friday afternoon thunderstorm. So now that we have a multi-year contract, we're actually expanding into major storm events as well, so hurricanes for that. But we also have several Australian clients who are expanding the use case into wildfire and how do they respond and what should their grid be doing, particularly in cases like in Australia where PSPS is not always allowed. So they need to have really up-to-the-minute predictions because they are at much greater risk than maybe American utility might be. We're also working with, very uniquely, some maritime Canadian and Northeast United States players to actually deal with two things. Tropical storms that are now starting to go up there with some regularity and winter storms. So there's a dual competing use case there, but really then it becomes a tool for all seasons, if you will. Does that answer your question?
Maybe to add on to Andy's question there, I understand you explained all the potential use cases from a utility perspective, but do you also anticipate your product expanding into forecasting events, like market events, like a winter storm, what it does to the wholesale markets and how companies can take advantage of that?
That might be Rev 3. We've actually already gotten interest from actuarial groups, from insurance groups around it, which is probably more the Rev 2 from a growth perspective. That could be Rev 3. But really what we want to do, we are very much a mission-driven organization. And our goal is really twofold. We want to help utilities, first and foremost, but then broader infrastructure companies deal with climate change and associated changes that come from the energy transition. Once we feel like we've actually achieved that goal, I think we'll start to look broader about what these applications might be able to do in a broader market context. But for right now, we're pretty laser focused on helping utilities make sure that they can weather the increasingly volatile weather that they're facing.
From a go-to-market perspective, would it make sense for you to deal with ISVs versus going directly to the utilities? And the whole thing is, it's great what you've accomplished. So what? How do you make it actionable? And would the solution being integrated with a work management solution, SAP, others, would that be a better go-to-market?
May I answer this? It is part of our strategy, but it's kind of an all-of-the-above strategy, to be blunt. We have several budding relationships with implementation partners who are also channels to market for us. So Big Four consultancies, a couple of other Accenture equivalents with whom we have strong relationships and growing every day. Thank you, guys. Appreciate it.
Our next presentation comes from ATX LED.
Good morning. My name is Murray Freeman, and I'm the founder of ATX LED. And we're a hardware company here based in Austin. And we are disrupting how light is, and also other low power loads, are actually wired in new home construction. So we believe that classically 120 volts used in every light in this room, for example, is really no longer the rational choice for lighting in new home construction. So Romex classically handles 20 amps, that's 2.5 kilowatts. The light bulb itself takes 6 watts. So let's use less copper. Tungsten, basically AC/DC agnostic, been around a very long time. That light bulb was designed over 100 years ago. I like to say that the indoor flush toilet is a more recent invention than the Edison socket. LEDs themselves are 3-volt DC devices. So inside of every one of those bulbs is a very poor quality, short lifetime, bad electrical load. So let's eliminate these bad converters. Anecdotally, by the way, every light bulb in this room, we can actually power with DC, including these bad sockets. So by getting rid of the AC and the phase-controlled dimmers, using DC, we can actually achieve perfect dimming. Once we have perfect dimming, we can now balance the current between 2 strings of LEDs and achieve color tuning. So we can take the lights in this room and change the color temperature between warm and cool. That's not exactly revolutionary. People like Ketcha do this at $1,200, $2,000 per fixture. We're doing this for less than 15. And that's really the big shift. We're also learning that when people have dimmers in a home, they actually use them and they reduce the amount of light. So we're looking at typically around dimming 40 to 60% below what would be the power used in a spec home with no dimmers. And since we're converting the AC to DC centrally one location, we're achieving a power factor of almost of 99%. So the quality of our load is a much better load. 1 million homes is the market per year. It's a mix, 900,000 single family, and then about 300,000 multifamily units. Builders are telling us that they're saving a lot of money in every home by using smaller wire, 18-gauge wire instead of 14 or 12-gauge Romex, and that pulls faster, so it's less labor. We've been doing this since 2018, been selling through trade shows to builders, electrical contractors nationwide. Trade shows kind of shut us down in 2020, but we continue through that base that we've established. We've got about 120 completed projects and a lot more in the pipeline. We're in like 20 states in the country, certainly a lot right here in Central Texas, but everywhere, Hawaii, Alaska, everywhere is using this technology. There are people in homes every day using this technology, and it's normal. We can go through the long list, I don't have a lot of time, but basically, just believe me, 120 volt wiring for light and for exhaust fans, ceiling fans, USB chargers, all these sub 20 watt loads is simply not really appropriate. So we're doing all this with low voltage DC. Architecturally, really very, so if I get the pointer right, somewhere there's a pointer, here we go. So we're bringing in the 120 volt once, converting it down into a 51 volt backplane, if you want to call it, using redundant power supplies. So if one of these were to fail, the house isn't dark. We now build a low voltage DC bus for the entire house that goes to the switches, and the switches goes then to the lights. The lights they look like these. Other ones look like those. And basically the user doesn't know or care that it's a DC environment. His or her switches are conventional. They look like regular wall switches, no training required. But if they want all these switches, not the bulbs, but the switches can communicate to Alexa and Google and all that kind of stuff. So that's a very simple architecture. It mimics kind of the conventional AC architecture, but all this is done essentially with 18-gauge wire as opposed to 14 or 12-gauge wire.
All right, and that's actually time.
Okay.
So judges, your questions begin now.
You focused a lot on the cost savings for wiring. Is there associated energy savings with all these AC to DC conversions? Does it add up to something significant in a home scale?
There is, but it's not that much. Basically, we achieved 90% of our efficiency savings going from incandescent to LED, right? What's left is a relatively small amount that we can squeeze back and forth. So it's in the neighborhood of 5 to 10% on an equivalent electrical load. But spec homes have classically no dimmers. And homes that are using our technology will then have dimmers. So the energy consumption is really coming from dimming down the light levels to lower levels. There's a slide here which I could pull up, but it actually is showing the energy consumption through the day for a typical house. A 3,500 square foot house, that's my slide we can't see, is peaking at around 200 watts for the lighting, right? But you have to provision 3,500 square feet. The code requires you provision 3 watts per square foot, so you got to provision 10 kilowatts when you bring in the amperage service of the home. So you got 40 amps, right? When you're actually never going to use more than 4 amps in these houses, right? So a single a single breaker, when they're not really smaller than 15, is all the lighting for the entire house, right?
Can you talk about, so you have 120 houses that you've done this in. Can you talk about some of the lessons learned or some of the biggest challenges that you've had to overcome in accomplishing this?
Yeah, the big thing right now is training videos, training content, and so on. We have a lot of electricians who basically have to learn how to do this 18-gauge wire, and it's not a big deal, but they're like, hey, it's something different, I don't know it. So training is a really big deal, and our major production now is hardware design is great and done, but generating more training videos and more training content, and CEUs, because there's continuing education.
And how long does the training typically take?
How long is it?
How long is your training?
An electrician, if we can get his attention, he can spend a day looking at our videos, is good to go.
Talk about the kind of the next level. We've got DC in the home now as a service with these lights. What's the next thing to get converted to DC after lights?
So the lighting, ceiling fans, exhaust fans, USB chargers. USB is pretty much universal. And we had a little outage a year ago and people had to go to their cars to charge their phones, right? Because the grid was down. In these homes, if we put a battery backup into the system, and by the way, the 51 volts, it's kind of a sweet spot for energy storage. We can avoid the inversion. We don't go from a battery up to 120 back down. Again, we just go straight from the battery into the DC infrastructure, and then we feed our USB-C chargers, which then drive your laptops, your phones, and so on. Your internet, by the way, my home, of course, like everyone else's, was off power a year ago, but people didn't realize that the fiber to their home was still functioning, right? So all I had to do was just take one of my batteries and power up my internet router, and I actually lit up the lighting in my home, obviously, and all that actually works, right? Because the infrastructure of the fiber wasn't down, right? Just that you couldn't actually use it in your home. So there's other loads. All the loads that are in that 20-watt category. There's a completely different conversation about DC 380 volts for the high-energy loads, HVAC, car charging, microwave ovens, all that stuff is basically there's a trajectory with DOE for the high voltage, high power loads, right? But that's a completely different conversation with a small number of high value, high energy loads versus 60, 70, 80 light bulbs, right? So we're focusing on the volume and staying away from that 380 volt conversation for now.
All right. Any more questions? Any last questions from the judges?
Are you talking to home builders to scale this, or are you doing one-offs?
The whole point of this really is to engage. There are roughly 25 builders in the country that build half the homes, right? The other half are built, it's a very long tail. People building 10 or 20 homes a year. So it's really a long ramp. But the top 25 build over half of them. And these are the people Lennars, Pulte, KB, all the folks that we're talking to who actually can move the needle. It'll take too long to move the needle dealing with people that are doing 10 or 20 houses a year. But you can't get to the top without going through the proof of concept. So we've spent all this time, the last 5 years in design and 4 years building houses. The very first houses I built in Austin, because I was the first guinea pig, right? So the first ones I built and sold, and essentially if we don't get UL listing, if it doesn't work, you can't sell the houses. So prove that, moved ahead. But the real target is clearly the Pulte, Lennar, KB, Meritage, the top builders.
So quick question. As a homeowner, if something were to go wrong with the system in a house that you sold and say that you're no longer available, can somebody just come in after you and take care of it?
I get that question a lot. And basically, the reason that I'm here is to actually resolve and solve that longevity question, right? Because they're looking at me going, hey, Mr. Freeman, it's great, but what about 5 or 10 years from now, right? First of all, the infrastructure, the wiring diagram, the training we're doing, everything is independent of our technology. So we're going to use skinnier wire, but whether my company makes the lights and dimmers or somebody else doesn't really change the wiring. Because that wiring is going to be behind the walls for 50, 60 years, right? So you're looking at, hey, what's happening down the road? Well, we're fairly certain that the energy consumption per light bulb is not going to increase. If anything, it's going to decrease. So we don't really need to keep putting 12-gauge wire in there. There's no reason to go back, right? So the wiring infrastructure is agnostic. It's designed to be, universal for anybody. But right now, yes, we are the only people crazy enough to be actually doing this.
All right, and that's time.
Thank you.
Thank you.